And now let's look at hotspots. So let me start by saying that we don't know what is causing a hotspot to exist. All we know is there's something hot deep down in the mantle, and that is causing hot rock to rise up under the lithosphere and eventually melt when it gets close to the surface, and that forms a series of volcanoes at the surface. And the plates seem to move around over these hotspots, but the hotspots themselves don't seem to move, or at least if they do, they don't move very fast. So let's look at a couple of examples of hotspots. We're going to check out this one down here. This is the Easter Island hotspot. And what you can see is that there are some earthquakes there, and they're kind of scattered around. So it's not the most explosive active area, but there is earthquake activity there. Let's look at that same area over here on Google Earth. And what you can see here is there's Easter Island, and let's zoom in on that. And it does look pretty volcanic. If we zoom right in on it, you can see a number of different craters here. All these little cinder cones across the land here, larger calderas in a couple of places. So this is Easter Island, famous for the large carved statues. And we're going to zoom out here, and we can see that the volcanic activity has been most recent in that area. And that as you look off to the side, you can see that the plate, in this case the Nazca plate, is moving away from this spreading center here, and it's carrying those volcanoes off of the hotspot, and they're moving along here. So the farther you get, the older these are. All the way over here, you have ones that are over 25 million years old. So it has moved approximately that far in 25 million years. Now, another example of this is actually on land. So let's go look at Yellowstone. So here's another place. Let's zoom in, and we can see where Yellowstone is right here, and that is the current location of a big caldera, which is a type of volcano found on the continent sometimes. And it's sometimes been dubbed a super volcano because when this one erupts, it erupts very, very big. And you can see that this was the most recent eruption here, about 600,000 years ago. And then as you go westward, you can see that there are older and older volcanic rocks heading all the way to the Columbia River area out here. And so we can really trace that hotspot pretty far across North America. So North America is moving westward, and these volcanoes keep forming and then moving away from the location of the hotspot right there. And let's go check that out on this area. Let's deselect this. We'll go out. Again. And let's see what's been happening here. Yellowstone. It's right in this area here. Yellowstone National Park, and let's select that area. And we can see a lot of earthquakes in that area. And let's look at them in other formats. We see that they max out at about a 5.5. So they're not the biggest earthquakes in the world. They're actually pretty small. And we can also look at that in 3D view. And what we'll see there is that they're pretty shallow and not going too deep in that area. So, and there is hot stuff moving up under the crust here, but it doesn't cause earthquakes. So we don't see that in terms of earthquakes. And that's about it from hotspots. You end up with just a chain of volcanoes, most of them extinct, with one or two at the end of the chain that are still active. And they are useful because they do help us to map out the direction that the plates have moved over time.